Hello, welcome to my YouTube channel. I'm Gustavo, and I'm going to be showing you my Law of Conservation of Energy in Collisions code. So let me introduce to you why I created this code in the first place. So basically, I was in physics class, and we were learning about this concept of Law of Conservation of Energy, and I thought this concept was really cool, you know. So I guess I was playing around with Python, right? So it was like PyGame, stuff like that. And then I decided to, I don't know, like create something that would actually show the law of conservation of energy on the computer. So that's what I'm going to show you today. So here, let me boot up here. So it first asks you to find the mass, or to tell them the mass of the first ball. So I don't know, I'm going to set it to like something like 3. And for the second ball, I'll set it to 1. And I guess for 6, the other one. This is on meters, or grams, sorry, kilograms. And this one, velocity, I think I'll set 6, I don't know, -2, and then 4. So it'll run here, you can see the balls hitting each other, and you can see how all of the kinetic energies stay the same, or they don't stay the same, but like the total energy of the balls stay the same, but like you're constantly changing, right? The velocity is constantly changing, it's not staying the same at all. You know, which I think that's really cool. So yeah. And we'll let it run a little bit. And I guess I'll show you the code while it's running here. So here, scroll it up. So you have the, so first you set up the user inputs, right? So like the ball, the mass of the yellow ball, green ball, the velocities. And then I'd have it where if you put in a small value, it would be, it would have a smaller ball, like the green ball, that you can see in here. But if it was like between 2 and 4, it would be a medium ball like this one. And then if it was a big ball, or if it was more than that, it would be the red ball, like the red ball. That would be big like that. And I do that for all of them. So then you would see here, and then I would have draw here, where it would show, you know, all of the kinetic energies and like the calculations of that. And this would be, you know, where it would actually put them down. And then place the balls, obviously, and then the update, kind of the bread and butter of it, where it would kind of like update it, so it would do this every 60, it would do this 60 times every second. So you can see here, this is where it's like you set up like kind of all of the stuff, where it's like it would move with like the velocity that you set, and then you do and then this is where it would, like, if it collided with the wall here, like there, it wouldn't just go flying off the screen, right? So then the ball collision here is like where it would actually collide, and the physics come into play. So you use the equation for the collision, like the final position after the collision, and you do this with both. And the reason that you use a different variable than the standard one would be because if you don't do that, it'll end up screwing up the values, because it would replace like this value, like the SP1, before prematurely, and it would end up screwing the values, and it would pretty much crash the thing. So you do that for both, and you end up, you know, that all of that you'd use to get that. And then the reason that you have stuff like this point here is because it's like, with the update, it's not like the ball's actually moving on the screen. It's more like it's teleporting whatever distance you tell it to. So it's like if you put the distance of, if you put the velocity of -2, the position will be going down -2 pixels every 60 times in a second. So to avoid it, so if the speeds get too high, it'll end up teleporting inside the ball, and that will cause it to crash. And then this line of code is supposed to counteract that in order to force the ball out of it, or not to force the ball out of it, but like just it would end up getting stuck on the wall a lot. So you'd have to like forcibly stop it to go out, essentially, if it were at the wall and it would hit at the same time. So yeah, that's my code. So you can see it's kind of running here. I think it's pretty cool how it can functionally do that. and it would never slow down, you know what I mean? Like, there may be some instances where the balls are slowing, but then the energy will never cease to go zero, you know? Which I think is really cool. So yeah, thanks for listening to me ramble about my code that I made. Okay, thanks for watching. Signing off.